Okay, so this is the Holochain Amateur Hack Club number 4, March 1st, and we're going to be looking at cointoss today and seeing if we can add a dice feature or get started adding a dice rolling feature. So I'm going to share the screen with Adam, which has the code in it. Cool, so I'm doing screen sharing and then also, oh, I have to update teletype. Maybe it will be a little bit less glitchy. Okay. Okay, I'm putting the link to Adam in the chat here. Yeah, so let's not worry so much about testing the apps out today because that took almost 2 hours last time. Let's just dive into the code and take a look and then see if we can add features. Can you two remind me your familiarity with programming and with Holochain programming in particular?
No familiarity. I'm learning actually. I'm just getting started.
Mm-hmm.
Yeah.
Okay, that's fine.
But I was able to install Holochain and a couple of applications like
Cool.
Clutter and cointoss the last time.
Cool, great. So, excuse me, I'm having an orange. If you have any questions at all about programming, even if they seem like basic questions, go ahead. That's perfectly fine. And I'll do my best to answer, and it will be helpful for people watching the video later too. And Vali, could you remind me your programming level?
Yeah, that was me speaking actually.
Oh, I'm sorry. The picture's I'm still learning your voice.
That was Vali speaking.
Yeah, sorry. And John?
I'm an experienced programmer, but Holochain is a mystery to me. So this is why I'm here.
Okay, great. So here we go. We've got, looks like I've got it open twice. Oh, and you're both following along in Adam, cool. Yeah, I'll just leave the screen share going though so that it's recorded. So, okay, so let's just do a quick overview again. Here's the index, which is the GUI, the GUI actual instance definition, and then cointoss.js here. These are functions which link the GUI elements to using the send function to the Holochain API, which is effectively the backend. And then hc.js contains the send function, which is used by all the functions to communicate with JSON, REST, POST in this case, API, sending those POST requests to the Holochain backend, which is executing locally and syncing globally. And then on the backend, or you could call it the side end, we have cointoss.js. This is where the actual Holochain functions are. So this is the code which is replicated on every Holochain node. And we have this sets your username, this gets your username. Here's some helper functions, some wrappers. This, and then remember, we should look at the cointoss theory again on the repo. Actually, let's take a glance at that now, because there's this process of commit toss. Let's actually, the first thing we'll do is we'll rearrange these functions so they happen in the order that it happens theoretically. So will be less confusing. So let me share my browser window. Great, so here's the cointoss repo, holochain/cointoss. And by the way, the Holochain repo, the Holochain core repo, has moved into this repo as Holochain proto, so like prototype. So it's no longer under metacurrency, so it'll be easier to find. Okay, so trustable random initiation. Okay, so let's read this. In a distributed system, we want to be able to design an interaction in a random fashion, i.e. have a coin toss as to who gets white for a chess game. In a distributed system, we must come up with a solution whereby the randomness available to the two parties is combined in a way that both parties can trust the other party, can't control or predict the outcome ahead of time, and thus win the coin toss. Very much like a real coin toss, where the whole point is it's done right in front of both people and nobody can influence it particularly. So the cointoss app achieves this in the following way. Alice requests of Bob to toss a coin by committing a seed with the following data. So that'll be a randomized seed, taken, seeded by the clock time. Salt, a random string, and seed value, here it is, a randomly chosen number between 0 and 9 to private chain, and then sending Bob a hash of that seed via node-to-node communication. So yeah, so the salt is the random string, and then there's also a random number. So it's actually two random things that are combined together in a hash. When Bob receives the request, and let's look in the code for that actually. This is committing a seed. So here, I'll just share my whole screen. And then in Atom. So first we have, yeah, see, I don't know why they didn't put these in order when they made this. Oh, and let's do a git pull to make sure we have the most updated version. So cd git repos, cointoss, and then I believe it is git pull. Uh-oh. It's not a git repository. Uh-oh. Well, it really should be. Okay, so I think just to make sure we're doing this right, I'm gonna reopen this project. I don't know why that's not a git repo, but let me pull the actual git repo. I probably there was some kind of glitch or incompleteness in the way that the command, the Holochain command to clone this, that clone example command, did it. So let's see. I'm gonna just delete that so I don't get confused. And then git clone, can't type today. My space bar is kind of broken. And then that. There we go. So now if we go into cointoss and we type git version, we'll have the most up-to-date version. Or that's, never mind. I don't know what that command is for that. And then if we do git pull, it's already up to date. So it will say it's already up to date. Yeah. Cool. But now I have to reopen it in Atom. Here we go. And resharing the teletype code. Okay, there's the new teletype code. And let's go back to this. Oh yeah, so we were looking at cointoss.js. We're looking at the commit seed function, and this is the first function that runs. Damn it. I'm so sorry. Okay, I used Dvorak, and Atom doesn't respect Dvorak, so when I just went to cut, this is the one program that doesn't do it right. It just killed the whole program, so I have to be very careful to not cut anything with keyboard shortcuts. Okay, here we go again. Resharing the Atom code. If we didn't do this at least like 3 times in every hack club, then it wouldn't be right. Okay. There we go. Commit seed, and we're just going to move this to a place that makes more sense, which I think here seems fine. Cool. And then let's actually comment this really nicely so that future people will have a good description. So this commits a random seed, or we'll say number 0 through 9 plus a salt, which people know what that means, or they can look it up. Commits a random seed number 0 through 9 plus salt to the local chain. I think that's all we need to say. So here's what it does. It creates a seed with 2 math randoms, maybe just to make sure there's no possible way that you could guess it with the current time. And then returns the commits it to the chain, and it returns which will return the hash of the address of, the hash is the address of the new entry. The type is seed, and then the content is the salt plus, so this is a string appending here. It's gonna, because of this string here, and then it will add, here's the number 0 through 9. So it's gonna be a long string with 2 math randoms appended, and then also the number 0 through 9 appended, committed to my local source chain. I'm pretty sure it's the local source chain. Cool, so there's the first function. And let me know if I'm going too fast or too slow, or would one of you like to take over and actually do this for the next few functions? Because this is really easy. It's just comparing this page to this and then rearranging the functions so they match. Maybe Fally, would you like to do this? And I'll watch and narrate, or you can narrate.
I was just checking if I lost my connection to the portal.
On Atom?
Yeah.
Oh, did you see a minute ago I had to restart it twice?
Yeah, I saw that.
Yeah. Okay, so you're on, your icon is here.
Okay. But your latest change doesn't seem to appear on my screen.
Oh, great.
Funny.
Yeah, maybe you could try reconnecting.
Okay, I will do that.
And I'm happy to do this, of course, too, but I'm trying to have this be a little more interactive than just me talking the whole time. And this is usually what I like to do with code. I'm not an expert programmer, but I like to, when I get a piece of code, I like to make it my own by, refactoring it basically, and adding some comments and making it intelligible. And then we understand it really well.
All right.
So, yeah. Would you like to try taking this over for a little bit? Or not. It's okay. Either way.
I'm happy with the following for now.
Okay. How about you, John? Want to jump in?
For me, it's the benefit I'm getting is listening to you and listening to your stream of consciousness. It is good. So don't think it's
Great,
not working. That's it's a great way to teach, and I'm grateful that you're spending your time doing this.
Okay, great. Thank you so much. Yeah, I'm happy to do it. I just was inviting more interaction. Let's see what's next. First, that was 1. 2. When Bob receives the request, Bob similarly commits his own seed with the same structure as above, and then commits a toss with the following data. So yeah, they really did just put these completely out of order in the code, as far as I can tell. It looks like Bob will be using the exact same commit seed function. Let's put a comment to that effect. Let's see, the toss initiator does this first, then the other party commits a seed also. Okay, and then, yeah, it's not a great sentence, but it's okay. When Bob receives a request, oh yeah, and then commits a toss with the following data. Initiator, in this case Alice, initiator seed hash, the hash of the seed that Alice sent Bob. So that's Alice's hash that she just committed, I think. The hash of the seed. So, okay, so the hash of the seed might be the return value here, maybe. I'm not totally sure what this is yet. Responder, in this case Bob, responder seed hash, the hash of Bob's seed. Yeah, I think by hash they mean address. So the hash or holochain address, because holochain immutable memory is, what's it called? The content addressed. So the hash of the content will actually be the address. So I think when they say hash, they mean address and they're equivalent. Call, a random 1 or 0, equivalent to choosing heads or tails. So I don't get to choose heads or tails in the app. It's done automatically in the backend. Are you raising your finger, John?
Yes. I don't want to spoil your flow. But
no problem.
I'd find this really interesting at this stage. And it will expose how little I know. But with a Holochain application, because this relates to you reordering things so you can make sense of the code as well. My understanding is if you alter a bracket or a comment and rerun a Holochain application, its hash code then changes. So anybody else that you're connected with, you lose that connection. And I just wanted to know, perhaps while you're speaking, how, because I see that as a major problem. I just can't get my head around how that's going to work in the future. When the tiniest change will basically disconnect your community, your network, or what? There must be a proper word for this in Holochain, but it escapes me at the moment. So just loose it. You don't need to go into data. And if you want to defer this to another time, that's fine by me.
No. The whole point of this group is to have these kinds of questions come up and answer them. Yeah, no, you're absolutely right. And so, yeah, this will break the versioning. So both people will have to do a git pull to upgrade to the newest version of cointoss for them to be able to speak to each other. Otherwise, the hashes will be different of their app version, and they'll be effectively on different networks. And yeah, I don't know if there's a better word than network. So yeah, right now we're breaking the compatibility of the current version. And you're right, that does sound like a huge problem, and right now it is. But by version 1.0 of Holochain, it will not be a problem at all, because so there's 2 layers. You know, there's the physical code that if it changes at all, it changes the hash. And then there's the thing we actually care about, which is the meaningful protocols and data. So the rules, the validation rules, which are the meaning of the code, right? So the meaning of the code defines the functionality of the app and the meaning of the data, the validation that meaningfully validates the data. So what we care about is that that's the same for all of the app versions. They're all validating the data in the same way. We don't care if the substrate, the actual physical code, is the same. So what's going to be implemented are migration protocols and versioning protocols. And I don't know the details yet. Those are still, I think, being designed. I think they have a general design, but they haven't done a full spec yet. But that'll make it, what that will do is allow people to install a new version, and then other people, and backposting is the third part. So you'll be able to migrate to a new version. This will put an entry on your chain that is a version migration entry, and it will say, starting here, I'm not following the old rules, I'm following the new rules, the new version. And then you'll be able to do backposting. So you'll be able to post both a version of entry for one version of an app and also a different version, so that other people who are still on the old version can read the entry. And then you'll also be able to invite people to migrate. So the app will say, there's been an update, would you like to migrate? So that, in theory, should totally solve this problem. Programmers will have to think about it a little bit in how they write backposting functions. So there'll be a little bit of work for programmers, but it'll be very straightforward. And users will never have to think about it.
Right.
Yeah.
Well, that's interesting. The fact that it's not a side effect. It's a design defect that is to be designed away. It will go. I couldn't understand whether it was part of Holochain. That's the way Holochain should work, or it's something that you just described. Now it will go away over time.
Yeah.
So that's interesting to know that.
Yeah, and in theoretically speaking, this is the way it should work, because, and even though it's inconvenient to start this way, because it's like if you're writing a story with someone, if you're writing something with someone, and they live across the world from you, and we don't have the internet or computers, how are you going to write with them? You have to have a shared medium, a shared physical substrate. So you have to call them on the phone and synchronize what your pages look like with your typewriter, or you have to meet in person and have a shared piece of paper. So in this case, our shared medium is the exact same code, and that's where we start. And then from there, we have to build abstractions that allow us to partially ignore the substrate. So it's a pretty deep like physicalist idea, or like commitment on this platform. Is that anything else on that?
It's not a trivial problem to solve.
No.
No,
Yeah.
that's very clear. I appreciate that. Thanks, Anders. Substrate.
Thank you. So, okay, so commit toss, and there's all these parts. So initiator, let's search on initiator and find where that is defined. Oh, we're at the top. Okay, so initiator. Okay, so this is getting passed in. Yeah, okay. So this is getting passed in from send, which is here. This is going to send all this data from, I think right here. Commit toss. I think this is what calls the function. So this is what passes in. Yeah. So this is the app key hash. Here's the seed. Here's the agent, the response seed, and the response call. So I don't know exactly what all those are yet, but we'll figure it out right now. Oops. And there's another place where it's called. Okay. So initiator, and let's go back and forth between this and the definition. So yeah, so initiator in this case is Alice, and so that's her hash of her, I think, her Holochain app hash for her, and then the initiator seed hash the hash of the seed that Alice sent Bob. So this is the address of the Holochain entry containing the seed that was committed by commit seed by Alice. And then there's the initiator seed, which is me. So I committed a seed, Bob committed a seed, and this is the hash or address of that Holochain entry. Responder, okay. Sorry, I'm one off. Here's the initiator seed, Alice. Initiator, this is the app, I think. This is the app version, and the seed of the app version, I think, or something like that. So this is not, and then the content starts here. So this is Alice's seed, this is me, this is my seed, and then this, oh no, sorry, I was right the first time. Anyway, so yeah, Alice's seed, me, my seed, and then the call is 0 or 1. And all of this is passed in. So this gets called somewhere else. And maybe we'll look at that in just a second. So commits a toss entry to the local chain. That's all we need to say. Yeah, we'll look at other functions after we arrange these. How about? So after making these two commits, for those two commits, Bob responds to Alice's request with a triple: responder seed, toss hash, and call. I don't see where that's done. Yeah, well, let's keep going. We'll figure this part out later. When Alice receives a response from Bob, she now commits a toss on her chain because she now has all the same information necessary to commit that value. Okay, so let's say the second party does this first, then the toss initiator. Okay. At this point, the actual coin toss has been completed because both parties have an entry that hashes to the same value on their chains. The winner of the toss, there's a typo there. I'm going to fix that. So where's the edit? Do I have permission? It looks like I might not have permission to edit. Oh no, I do. Yeah, so if you guys haven't used Git a ton, or if in the audience watching this video, it's really easy to edit text files, and these are just markdown until it changes font size. There we go. The winner of the toss is defined as follows. I fixed a typo, propose the change. Cool. It looks like I do have access, so I can do that. Okay. And I'm not going to refresh, but if I did, that change would be there. The winner of the toss is defined as follows. The responder wins if initiator seed value plus responder seed value modulus 2 is equal to call. This was meant to mimic the way the initiator flips the coin, but the responder makes the call. So it just adds their seeds together and then divides by 2, and the remainder is either 0 or 1, and that will match the call that was made. And where is this? It's not, this documentation is not totally clear because it's not saying what function it is, but I think it's confirm seed, maybe? Confirm toss. Okay, so I think probably both confirm seed and confirm toss occur. No, I'm sorry. I killed Adam. So sorry. Yeah, like I said, Atom is the one program on my computer that does not respect the keyboard layouts I have set up. So that means they've probably hard-coded the keyboard layout into the app, which is a huge no-no. Really bad for like accessibility and that kind of thing. Okay, so I just pasted the new hash to this new Atom session. So sorry about that. And let's see if it deleted my changes. Nope, it saved them. So that's nice. Okay, so we've got confirm seed and confirm toss. If I press Control B, that's Control X. Okay, so I think we want this here. Cool. And then we've got, I think request toss is actually the very first function that gets called. Before even commit seed. Yeah, I don't see the comment. It initiates. Oh, I guess I'll follow their comment convention and decapitalize these. I love decapitalizing things. Okay. Initiates node-to-node communication with an agent to commit seeds values for the toss, followed by the toss entry itself afterwards. So let's actually walk through this function line by line and see if we can figure out exactly what it does. So first we make a variable mySeed, and that equals commit seed. So this calls commit seed on the current instance of Holochain. And then the response is equal to, it parses the JSON, it sends a request inside of this. So first it sends a request to request.agent of type toss request with my seed. Okay, so first I commit the seed. Let's comment the shit out of this. Okay, so commit my seed to the local source chain. Send my seed in a toss request to the other party. Also, what was the word they used? It was a nice word. Responder, to the responder. Send my seed in a toss request to the responder and save the response. Yeah. Create our own copy of the toss according to the seed and call from the responder. Okay, so then we make a variable called the toss, and then we commit the toss with my app key hash, my seed, rec.agent, which is probably the other agent, because that's who it's being sent to right here, response.seed, so the seed they sent back, and response.call, which is their 0 or 1 call.
So line 77.
Yes.
What you've done is you've created a variable to a function, commit seed. So
no, I'm storing the result of commit seed in a variable.
Yes.
Is that what you meant?
Sorry. So it's the salt and the random, the variable between 0 and 9. My question is, what's the local store? So I'm going back to just basic Holochain. Is there I know there's one out in the cloud somewhere. You don't use the word cloud. I know that's a bad word. What do you call it?
Yeah. Yeah. No, we don't. No, I think we do. I think we usually reserve the word cloud for what the Holo app will do. The DHT, the distributed hash table, is what we call it.
So there's a DHT out there somewhere. Then you're talking about this local source chain.
Yeah, I might be actually saying this wrong. I'm a little bit fuzzy on when things are in the private or like local as private, where they're only local and they're not shared to the DHT, versus when they are local and also being shared to the DHT. So I might have to come back and change this. I'm not sure local source chain is correct. It might just be my source chain. But I think local source chain is then automatically gossiped in most cases. Yeah,
What was the word?
but I'm fuzzy on that. Mm-hmm.
The word you used then was gossiped.
Yeah, the gossip protocol is how the source chains which are local are then gossiped out into the DHT. The gossip protocol kind of makes the DHT. Cool. So yeah, I'm sorry about that. I can check on that. Let me make some notes. Actually, in Mattermost, what was the first weird thing we ran into? There was a little glitch or a little confusion. I can't remember.
It's I can't pronounce your name now. Fale. Are you aware of the developer portal for Holochain?
Yeah, I had a look at it. Yeah.
Okay. As you weren't here on the last call, I wasn't on the first hack, so just in case you missed that.
Yeah, thanks. It's very useful, actually.
Cool. Yeah, so sorry I can't answer that definitively, but I'm going to ask people about that. And I'll post the answer in Amateur Hack Club. Shall I continue?
Yes, please.
Okay. My tea. Okay, so yeah, so we commit the task. Hang on one second. Let me throw this. Sorry, I just made a mess. One moment. Okay, so we commit the toss, and then next we compare the toss to. So the toss is not equal to. Oh, I see. So this is we don't need to actually comment this because this is just an error check to make sure that it's not totally broken. And then we return the toss. Cool. So yeah, so this is commit seed and this is commit toss. So those are in the right order. And then I don't see where confirm seed is called yet. And then we have confirm toss. There we go. Okay, so when Alice receives the toss, she commits at this point. The trick behind this process is that before step 3 is completed, both parties keep their seed information secret after the two parties both have received confirmation that the other party has committed their toss to their own chain. There's another typo. The toss to their own chain in the form of the signed toss, then they can make their seed content public to anybody who asks. This is because after the toss has been independently committed to both chains, the two parties can't go back on their own contribution to the randomness that makes up the toss, nor can they predict the whether the other party. Let's fix both of those typos. After the two parties have seen the first can the toss their own chain in the form of the toss and they can make it. Because after the toss, the parties can't keep after. Where was that first type? Have both received that the other party has committed the toss. Oh, there it is, to their own chain. independently committed to both chains. The two parties can't go back on their contribution to randomness, nor can they predict whether the other party to the randomness that they committed to both chains, each person, nor can they predict whether the other party chose an odd or even value for the random seed by examining the hash of the seed, because that seed contains a long random salt, making it impractical to search the seed space, try to brute force a generation of a seed to match its hash. So if someone tries to mess with their seed after they've committed it, they can break the coin toss. They can make it so that when the other party checks it later and makes the comparison, it will fail, and it's not, the other party discovers that there's no longer the same coin toss happening. But they can't sabotage the coin toss. They can just break it. Okay, so let's figure out this code a little bit more, because there's still a lot of stuff here we haven't seen exactly what it does.
So all this integrity is being afforded by the blockchain technologies. I think for somebody listening to this, it's quite a big thing that if you've not programmed that before. Yeah,
and this is the new conceptual stuff that is also new to me. But yeah, the way that works and the flexibility that we have with it in Holochain's architecture is pretty revolutionary, actually. And of course, this all goes back to Shapiro's original blockchain paper, I think, which I've heard people say, it's surprising nobody thought of this before, but nobody did until that paper. Okay, so let's look at the bottom. We've got a bunch of stuff down here. Let's just start at the bottom and go up a little bit. We've got some validation functions. Some of these probably should be more filled out, but they aren't yet because it's just a demo. And they're still developing some of the back end that's related to some of these validate functions. So validate link. This is a link between nodes, between Holochain entries. Here's a generic Holochain validate function, which you usually do a switch, or in this case an if, on the entry type. And different types of entries have different validate functions. In this case, it just returns true. So that should be filled out with more validation logic, maybe, I think. Here's a description. Validation functions for every change made to DHT entry. Every DHT node uses their own copy of these functions to validate any and all changes requested before accepting. Yeah, so I think Holochain entries are shared into the DHT automatically unless you set them to private, and then they're not shared. But that's still that's not considered a form of security yet. Listen for toss request. So this is callbacks called by backend system instead of front end app or UI. Genesis is called only when your source chain is generated. So this when you generate your source chain, when you call the hcdev init function at the command line, that's what calls the Genesis function. So this is only called once when you first initialize a Holochain application, and this sets your handle. And then this is a callback. It listens for a toss request. So, okay, so this is actually an important function because this does a bunch of stuff. We should maybe comment this. So, excuse me. So a toss request would be sent by the initiator to the responder. So that means that this function is going to be activated on the responder. And this is what kind of sets off the whole chain of events. Let's take another glance at the toss request function. Request toss. So yeah, this commits a seed, this commits a toss. Oh, and this is the send. Here it is. So this is what activates the function we were just looking at. And it sends the seed and the type. And I'm not sure if that's done through a Holochain entry or through some other type of direct activation. It's probably a Holochain entry. Maybe not. It's a direct message, maybe. I'm not sure how this works here, but it will be triggered. And there's the two parts of information that was sent: the from address and then the contents, the seed in this case. So the type is equal to message.type, so it pulls the type out of the message. And then if the type is toss request, which it is because we just saw it was set to that, then it will, or it should be anyway, then my seed is equal to commit seed. So the other person has already committed a seed, so now I can commit a seed. And then we call whether we want heads or tails. And so we do math.floor, math.random times 10 modulus 2 equals 0. So this will return either 0 or 1. The other equation that was like this, there was another, this was written somewhere else. Let me find modulus.
I think that's a Boolean though, won't it be? With
Yeah.
So the
yeah,
call,
you're right.
yeah.
Oh, I see. So I see. So the modulus is done twice. Once when it does the call, and then once when it compares them. Yeah. See the there's just two moduluses in this. Yeah. But you're right. It's done as a Boolean, which is a little bit hacky because the types will not match exactly. But apparently it works. So they're converted. JavaScript converts lots of. It does not have rigid type checking. It has. There's this one video that Eric loves called WAT, W-A-T, and it's all about the weirdnesses of JavaScript. Yeah. So probably it just converts it without a problem in this.
The word. The concept they use is truthy, so I quite like that. Where if a string exists, then it's true. If it's something's not 0, then it's true. So
yeah. That's common in I guess truthy languages. Yeah, is that right? Calling them truthy languages, or is the value truthy?
But I think it's safe to say because it's not a type-safe language, you can test for things which are truthy. So it's like common sense, which I quite like about JavaScript. If you try and
really,
I
don't even like hearing the phrase "not a type-safe language."
Well, I don't like working in them because I like the compiler and the editor to help me out. But JavaScript is so popular that you have to cope with it.
Yeah, and I think JavaScript has gotten a lot better, but 10 or 15 years ago when I was first learning about JavaScript, I really didn't like it because it's so messy. It's still pretty messy. There's like 5 or 10 ways to do anything. But it's fine. It's better than it used to be, I think. And the tools for programming are much better. Yeah.
Well, I don't like it, but it's heading in the right direction. I don't know whether Farley agrees with this, but you've got TypeScript, which is like a superset, so you can have object programming with type safety. And then you've got Harmony, ES 2015, ES 2016. We're adding more and more. They're making JavaScript more feature-rich and more of a platform where you can develop larger applications. But what I don't like is in current versions of JavaScript. So you have to work on the lowest common denominator. We're going through a transition period at the moment, but there's a lot of code out there that uses callbacks. So you end up with this callback hell, and this is on the server side with Node. And I think that is a depressing, you know, to work in a job where you're dealing with JavaScript in that mess is, I couldn't cope with that. Just out of interest,
Oh yeah,
I don't want to go off on a tangent, so just pull me back and say, well, that'll be for another week or another day. But I hope at some time we can cover the DNA bit, which is the interface file to the Holochain like runtime. So that's the HC dev. You have an interface file, which I think it's called DNA.json.
yeah,
And then
that
allows us to program in JavaScript to talk to Holochain to do all its magic. I think you said last time that there was a Haskell project. Lisp, that's the one. Are there any other plans for other languages?
Not specifically, not yet, but it's an open framework, and I'm sure we will add other languages in there, and other people will add other languages in the future. But yeah, no, right now they're just plowing ahead with core Holochain.
My day job is researching skills for IT recruitment or the job market. And I think Holochain, I don't want to go off on a tangent here, by the way, we'll get back to where we were, but I think Holochain will explode when people start adding layers of abstraction. So kind of tool chains built on top of this. So we're probably dealing with like the assembly language or the very low level, and all these hash key generation and almost gymnastics that we're doing now will all become transparent. It will all happen, and you'll be dealing more with business logic. Send coin to Anders and receive coin to John. It'll be, that's how I see it anyway.
Yeah, I agree.
So there's probably somebody somewhere who's already working on this, and it's just a matter of time before we all get to see it.
Yeah, I think that's what we're planning on happening, is increasing abstractions and easy plug and play interfaces between the code, programming interfaces, not GUI interfaces.
Yeah.
I was going to ask though, where is JavaScript heading? You said we're in a transition period.
What's happened is people, IT departments, project managers see that the attraction, which I think is, I think it's a mistake sometimes, but they like to see isomorphic stacks are a way to get more productivity out of a team of developers. So you're dealing with JavaScript on the client, either mobile or browser, and then JavaScript on the server, or even serverless. That's where we're going, is serverless. So containers and things like that are a bit of a distraction. But the way you program on the client and the way you program on a server are completely different. So that mindset of saying, well, we can get productivity by using JavaScript on the whole stack, I think is a fallacy.
Yeah.
The fact that it's not type safe either, you know, for applications such as Holochain, where dealing with types and checking errors, etc., you probably do need that kind of safety built in. Now, the other thing that's important, because it's so prevalent, that browser vendors are actually being, you know, we could say that Google does set the agenda. I think Google is quite a good custodian of the web. You know, they didn't sit back and let Internet Explorer go nowhere. The Internet Explorer 6 is stuck in the Stone Age. The internet has to work for Google, otherwise Google doesn't exist. So they forced innovation on Microsoft by releasing Chrome. Now the V8 engine, that the JavaScript part of Chrome, is used everywhere. It's used in Node, It's used in Blink. Sorry, what's the other browser called that's become popular now? You know, the privacy one, Brave.
Oh.
So what that means, though, is the mind share of JavaScript is constantly expanding, which makes it more difficult for it to go away. I mean, I'm not explaining myself very well. So I think in our lifetime, we're going to have to get used to the fact that JavaScript is here. It's got that video, that very short video. If you've not seen it, it's hilarious. You know, that what?
Mm-hmm. Yeah.
So I think browser vendors are committed to improving the language, but there is so much give and take in the committees and the standards boards that often it can be plagued with politics more than anything else. So if Google have got Go, which is the language I use in my day job, and they're pushing that forward possible, but they also have their own the idiomatic, they call it, so their own principles that they want to apply to the language, and then they can control it because it's their project. Where JavaScript is shared across many, it's almost like the assembly language of the internet, because everybody uses it on the front end. So I'm kind of ambivalent to whether it's more that we're stuck with it. That's the thing. And it is gradually getting better. But as a language, it's awful. It really is awful. You know, if you've come from type safe like C, or, I mean, when I started programming, it was Pascal and things like that, which don't exist anymore. And what I like to do is work in a browser that's, an IDE that runs code coverage and things like that all in the background. That I want the computer to do all that heavy lifting and not me. I mean, you can do things like this now in Atom when you put all the plugins in. And it's easier to do that with type-safe languages. For example, TypeScript. But a lot of front-end developers don't like TypeScript because of the extra, you know, it's another layer of complexity from what you're trying to do as a developer and what the browser expects you to produce in code. So let me answer it in simply. I think that the outlook is mixed. How about that?
Yeah. Interesting. Yeah, that was very interesting. Thank you. I've never gotten like a good word on JavaScript like that before. And I've always hated it, and I've never known exactly why. and I still hate it. But I mean, look at this rat's nest. Look at this. And this is good code. This is great code. But it's because of JavaScript, it doesn't look that great. And the Holochain core is certainly not written in JavaScript because it's not type safe, but we have these validation functions, so we can explicitly check all of our assumptions on the data, whatever language we're using. Yeah. Anyway, thank you for that. That was really interesting. Oh, it says you both dropped out of the Atom portal. Are you still there?
You were breaking up a bit then.
Okay.
So we'll sign back in.
Yeah, sorry about that. I guess I had a bit of internet drop. Yeah, you can see my internet in my bar up here. There's a little spike downwards. Okay, anyway.
Kudos for using Ubuntu, though.
Yeah. One of my friends last March, actually during the Holochain hackathon, forced me to switch to, what's it called? The one that, Awesome Window Manager on that really cutting edge Linux distro that has nothing pre-installed. I'm forgetting I'm blanking on the name right now.
Mint.
But not Mint, the other one. Arch, yeah. My friend forced me to install Arch Linux and was like, you have to install Arch. And it was not a good experience. So I finally, it worked. It was great. It was fast. But after a couple months, I switched to Ubuntu. But I finally got away from Windows, and Ubuntu works lovely. Yeah. So let's get back to the coding. So call whether we want heads or tails randomly, and then we do commit toss. So I commit my toss. I'm just going to say the chain instead of the local chain in case I'm wrong. Commit my toss to the chain, and then return the value. Return the seed, the toss, and the call. And this will return here. This will return right here. And so then request toss can continue. Hang on. Yeah, then request toss can then go on to do the commit on the initiator side. Yeah, so it's like a little stack. It goes up and then it goes down. You're down here in receive. Okay. Else, if the message type is seed request, make sure I committed toss and the seed hash is one of the seeds in the commit. So this is double checking the record. So RSP, I don't know what that means. That's a value name variable, equals get message.toss. So that's the type. And oh, this is get from the chain. This is a Holochain core function that will check the local chain. And local true, so it's checking the local chain. Get mask is get mask.entry type plus get mask.entry. So I think this is probably the mask for the data type that it's looking for in the chain. I'm just guessing though. I'm not totally sure what that is. So that will get the RSP, whatever that is. If I knew more what this was supposed to be, I would rename this variable. I hate obscurely named variables. And then if RSP.entry type equals toss, which is, well, it's what it's supposed to be, but I don't see where. Anyway, then check then get the entry and parse it, and then the entry.initiator seed hash equals message.seed hash. I think this is comparing whether the hash is the same as the hash. Oh, this is checking. Yeah, this is checking to make sure that the hash that the other person committed matches the hash that they said they committed, I think. Or if the responder seed hash is, so or it's checking to see if it's my hash. So someone's hash is on the chain correctly. If so, then I can reveal the seed. So this looks like it happens later in the process when you're about to reveal the seed. And then you get the seed here and return it. I don't completely understand this yet, so I'm not going to add any comments.
It has
anyway,
to do with the NPM apparently.
The what?
The RSP var. It has to do with the NPM apparently.
Could you say that again? Or yeah?
I just did a quick search on RSP. It stands for radically simplified premises.
Oh, okay. Oh, yeah. Okay. So they're checking premises. They're doing some error checking. Is that what you mean?
I don't know. Let me put the link here.
Okay. Yeah, really simple premises. So simple that we don't know what it stood for. Radically simplified promises. Proof of concept that allows you to call methods on promises in the future. I see. So yeah, I don't think they're using this library, but they're referencing it in that variable name. Very obscure to me anyway. Cool. Okay, yeah, thank you for that, Valley. That explains it.
Yeah,
so yeah, so this is probably something that people in crypto know about, and they get this idea of a promise. Yeah, so you're checking the promise, and there's some promise logic in here that we could dive into, but I want to move on a little bit faster, even though I don't totally understand that yet. Okay, so let's go back to our main thread. Confirm toss, confirm seed, and let's look at the. Does scrolling look glitchy to you on the screen share, or are you both in Atom?
It's fine. I'm watching the Zoom.
Okay, yeah, my scrolling is a bit glitchy.
I'm watching the Zoom more than Atom.
Okay, yeah, no problem. Yeah, I think Atom doesn't scroll with the other person.
No,
so,
no, it doesn't.
Yeah. Okay, so we looked at this where the send request is received. So this is when a toss is requested. So when I click the request toss button, commits my seed, it sends my seed to the other person, and then they commit their own seed, and then they send back the address to their seed. And now I have the address to their seed in response, and I can commit my toss. And I think the other party already committed their toss as well. Let's double check that. Yeah, I commit my seed and I commit my toss, and then it goes back to the first party. And then I, as the requesting party, commit my toss. And then I check if the toss matches response.toss. So this is checking the validity here. And if it's not valid, then something has gone terribly wrong. Yeah, I don't see where confirm seed is called. That's what I'm looking for right now. There's confirm seed. There's, it's in confirm toss twice. Okay, so this is some kind of validation function, probably not a holochain validation function, but just a checking function.
so it's just another JavaScript truthy test for each one, though. So you confirm the seed, and if it's true, continue.
Exactly. Yeah, these are things that might be done away with in a more strictly typed or other types of error checking language. I seed, R seed. So many variables. Commit the toss result. Okay, so yeah, anyway, so I think confirm seed, I'm gonna put a question mark on the end of this, checks the validity of the committed seed. I'll put a question mark. Okay, and here we've got another reference to promises. Confirm toss. So initiates node-to-node communication with an agent to retrieve the actual seed values after they were committed, so we can find out what the toss actually was. Yeah, so first we put all these secrets in a box, and then we open the box and check the secrets. And that's a promise, I'm thinking. Yeah, so I don't know if we need to step through all of this, but because it'd be fun to start designing the dice functionality, which maybe should actually be a separate app, because it's going to have new interface elements, it's going to have new logic, but the main difference is actually just right here. Instead of win or loss, instead of modulus 2, we'll do modulus whatever number of sides the dice has. And we don't need to do the logic of calling the coin heads or tails. Instead, we could just remove that part and then do modulus, say for 6 for a 6-sided die. So it's actually a really tiny modification, but we do need to do a new interface element so that the user can type it in, or we need to hard code it. Maybe we should start with making just one button, and it's roll a die, and then that does a verified die roll between the two people, and we could have it default to a 6-sided die, so we can do iterative development, and then in the next iteration we can add a box that takes a number and also commits the number of sides of the dice to the request. So yeah, actually I think we could do it in this app. How does that sound? Do you guys want to try to dive into that? I might need some help. We have about 40 minutes left. We could get started on that.
Would it be possible to have a look at the DNA?
Oh yeah, let's do that.
Interface file.
Sure. And yeah, let's before we do that, really briefly, let's commit the changes that we made to the repo. Are you familiar with Git, John? Because I'm not super familiar with it.
Only the basic commands, but most of the time that's all you need.
Yeah. So what do I do? Git pull, commit, git pull, git push.
You need to do a pull request, and then in GitHub, if you got the rights, you can merge it.
Okay. So git pull. Okay. Can I do git merge here? It's already up to date. Sorry about the dog.
I use JetBrains, so I kind of do all this in my IDE. Just bear with me a second.
Yeah, I haven't done this very much, so I don't know how to commit. I thought it was git commit. Yeah, changes not staged for, oh, I see, changes not staged. So I have to do git, thank you. How do I add, is it git add? I think it's git add. I did it, and then if I do git commit, it works. Look, I got it. I remembered. Please enter a commit message for your changes. Rearranged. Rearranged Holochain. I'm supposed to capitalize Holochain. Holochain functions to match the order they are called in. Added comments, and then Control O to write, enter, and exit. One file change, 25 insertions, and then now I do get pull. No. Now I do get push. Yes. I don't know my username. Yeah. Oh no, I think my first password was right. Okay. Okay, I'll do this later because I have to figure out my password. But I think this is the last command, and then it will push the changes. So let's look at the DNA. Okay, so here's the DNA file. So this is JSON, structured, I don't know what JSON stands for, I don't remember. But this is a structured information about this particular Holochain application. Is this what you wanted to look at, John?
Yes, please. JSON, JavaScript object notation, so you can't get away from JavaScript.
Yeah.
I was just thinking about a group effort of a Holochain application, and I don't want to hold you back. You're the whiz here, but I wonder if we could just start really simple and start with that Genesis bit to start with. So if there's 3 of us here next time, and then just to be able to post messages to each other, because I think, and then our aim is to get to that dice game at the end to beat that. That's the summit to reach. Because I think if we sidestep the real core basics, because at the end of the day, these will never go away. Once the abstraction layers get built onto Holochain, those basic structures are fundamental to how the whole system works. So people like me who really, I see there's something about this which is, I've not had that feeling, and since the internet first came about in 1995, where people there was just a complete change of the way people thought where IT and computers were going. And with blockchain, Holochain, R-Chain, and all the other projects out there, I get the same feeling. So I'm prepared to put a lot of effort in to learn that. I'm sure I can't speak for everybody else on the call, but I think if you master the basics, then the rest should follow. So I'm not going to force that on you. I'm quite happy to go with the dive in the deep end, if that's what's.
So you're suggesting we start the Dice app from scratch?
Yes, that's probably a better way to explain it. Yeah. That's totally fine. That's a good idea, and we can of course copy over the code from cointoss as we go. But I agree. Yeah, it would be good to start the development process totally from scratch, and we'll run into problems that anyone would run into trying to do that, which is part of why I wanted to do this group.
It sounds good to me. Personally, I don't have a point of reference, so I'm diving into this with with a blank sheet of paper. So,
have you been able to follow this call pretty well?
Yeah, it's mostly over my head, but I get an intuitive understanding, I would say.
Well, feel free to jump in with any questions, even if they're really basic, just like syntax or anything like that.
Yeah, it seems to me that when I did some search online, I was able to find some indications. But yeah, not at a point where I can clearly formulate where I don't understand. So I'm not at the stage where I can formulate my misunderstanding yet. So
okay,
I think I'm with you on that. I'm there too. So that's good. But that's not your criticism of you, Anders. I think where you get lost in this is dealing with all the hash and the seeds, which is the protocol. So that's, I think the application is understandable, tossing a coin, working out who has won and lost. It's the Holochain protocol that I think it's fair would find anyone will find quite challenging at this present time. But I think if you've got the patience, maybe this time in 3 months, 6 months time, you'll be able to do live coding at a conference. Use as a practice. Yeah.
That would be great. I think that's one of the purpose of this kind of meetings.
Yeah.
Yeah.
Exactly. Yeah, it's slow going, but it's also rich because we're going into all the little details. We're taking the detours, and I think that's where a lot of learning happens.
Yeah, for me, like it's like a big accelerator.
Great, awesome, thank you. Cool. So let's look at this DNA file. So you just wanted to understand this file, right, John, and go into all the details? Yeah. Okay. So yeah, here we go. Oh, go ahead.
I just wanted to leave my mic open in case you ask me a question. It's really, why is it there? Why is it needed? And
Yeah.
then, but what works for me is understanding the way you understand it. I think it's a great way to learn.
I don't completely understand it.
But
I'll do my best.
To get to your level is that's what I'm here for. So I understand if you were to say, I don't fully understand that, well, that's fine. But to understand it at your level and how you see it and how you work with it is good enough from where we are today, I think.
Thank you. Yeah, and I've just
said it's an accelerated way of learning. This is the best way to learn Holochain. Thank you.
Thank you very much. And yeah, I haven't been heavily exposed to Holochain programming. My main exposure is I went to the hackathon, which was it 2 weeks? 1 week, 1 week, I believe, last March. So I got to work with Art and Eric, and Nico was there, and Daisy was there. I think Nico was there, yeah. So I learned a bit from them then, including some pair programming. But yeah, so anyway, I think the DNA file, it might actually be the DNA file which is hashed and not the code. So it might be that it's changes here that change the definition of the Holochain version and not the code. But I can't remember. It might be both. They might just be appended and then hashed. But I can't remember. I don't know. Anyway, so here's some type of versioning. We'll just go through this line by line, and please interrupt if you want me to go into more detail or figure something out. UUID. Yeah.
Yeah. Sorry, Anders. There's a page on the developer portal which goes into application DNA.
Oh, thank you. Yeah, let's take a look at that.
It describes what it means. Hold on a sec. Here's the link.
Thank you. I'll just find it.
Yeah.
I hate clicking. My screen is high resolution, so a little chat button. See, it's so tiny. Here, no, I got your link now, though.
I think it's the first one. Yeah. This one.
Yeah. It's embarrassing that they don't have resizable GUIs at this point with vector graphics. Anyway, yeah. So application DNA consists of the DNA file at the core in which a number of application properties plus application code and entry types are specified. Each Holochain app has a DNA file at its core. Yeah, and it defines the app and its basic structure. The fields to be specified are as follows. Version, and let's just go back. Double clicking in this deco, and it broke my back button. Come on, deco. Come on. It does edit mode. So let me just sign in. So if I double click, it won't break my back button again. Okay. There we go. Okay. So I was going to double click to just select, but I will do this. Version, an integer value describing the version of this DNA file. So version 0, this probably should be iterated at some point. UUID, these are unique generated strings of random characters that are used to identify hardware and computers and other unique things. I think one of those U's probably stands for, I think it's Universal Unique Identifier. A UUID, make sure your new Holochain is unique and doesn't accidentally this should say Holochain app, and Holochain should be capitalized. Here, let's just stay in edit mode. I'll tidy this up a bit as we go. Make sure your new Holochain app is unique and doesn't accidentally collide with the Holochain whose code you have. Oh no, it does mean your Holochain, not Holochain app. The app also, but it means the holochain itself. You don't want it to collide in the gossip. So when you have a new holochain, you have a different UUID, I suppose. For example, if you want to create a new and different instance of a chat application, you can clone the DNA of a chat, and the fact that we generate a new UUID for you will keep you from accidentally creating a new chat team in the same data space as your old one. So same app, different instance within the decentralized hash table. Thus, when creating a new app, you should use hcdev init clone source app rather than simply copying the files manually. So, okay, so the DNA file is an, if I'm understanding this right, this is an instance file. So if you have multiple instances of the same Holochain app, both, and when I say instance, that's both individually on your computer, but also in general, abstractly, in the cloud, in the DHT, it's a different instance. So when you init the app, maybe it's actually a different UUID in a different instance, but I'm not sure on that. And then name, string value of the name of the application. This is straightforward. cointoss requires version at least Holochain 17. Right now we're on Holochain 19 alpha. Properties, a hash map of app-defined strings that are available to the app via the property function. This is especially useful for applications that will be cloned and customized. We have a description, simple end-to-end app, and a language, just 2 properties. And then we have a properties schema file. Okay, so there's some stuff here that's not documented, that should be documented, but I am not the person to do that because I don't know what these are. So there's a properties schema file, which is referencing this file. So this is defining the title, type, properties, name, type, string, description, string. Okay, so this is defining the structure of the properties. So we have a description in a language, and that's here, description and language, and then the properties schema file defines their data types of the properties. So yeah, I could add that, but I'm not going to spend time on this call writing new documentation. And then DHT config, hash type. This sets the hash encryption type in the DHT. And based on, this is, I think, kind of more qualitative metadata, where you say the which app this is based on. I think this is going to be used for the migration and backposting and versioning protocols in the future. Excuse me. Zones. Okay, so now we have some more documentation. Zones. A Holochain application may be broken into different functional domains called zones. In keeping with the biological language of DNA and the different ribosomes as the virtual machines that run the DNA code, it seemed appropriate to think of these functional units as chromosomes, which is way too long to type, so we went with zones, which is confusing because then it sounds like ribosomes also. But yeah, zones are the chromosomes of the app. One example of why you might have different zones is that you may be mashing a few different Holochain apps together into a new unified Holochain app. Each of those previously separate apps could be a zome in your new app. Additionally, they are a unit of composition as they can be easily mixed into applications when they're being built like code libraries. So yeah, this is the core definition of the app. Each zome's section contains some basic information about the zome, name, description, ribosome type, code, file name, hash of the code file name, hash of that file, etc. Oh, this is it. This is so key. Okay, this answers the confusion that I was having about what is hashed. The DNA contains the hash and the file name of the code which is being hashed. So the DNA contains the hash and it's distributed. And I think that hash might be the hash of the file plus the DNA. So it's hashing itself, including the hash. See, and then you can't edit it. It's indestructible. You cannot, you can't spoof that. There's no possible way unless you break all cryptography. Okay, so yeah, this is absolutely critical concept right there. As well as identifying what entry types or data structures are used within this zone, and what functions in this zone are available for calling from UIs or from other zones. Cool. Yeah, I'm so excited I found this because I couldn't remember the detail there. Name of the zone, coin toss. Description, zone that uses node to node for co-signing of a coin toss. Ribosome type, JS. This is important. This defines the language that we're using to write the Holochain functions, which we were looking at before. Like I said, there are two options now, JavaScript, or there's a dialect of Lisp. I forget what the dialect is called. Code file, cointoss.js. This references the code file. And let's find that hash because that's important. It's not here. Okay, so the hash should be here. Maybe when, okay, so I'm still a little fuzzy on this. Maybe it's not implemented yet. But anyway, there should be either a hash here or maybe once it's instantiated, maybe that's when the hash is added. Cool, and here are the entries. So these are entry types. Let's go back over here. Ribosome type config, a map of zone specific configurations. We don't have this. Yeah, we don't have that. Code file, we looked at that. Bridge functions, this is gonna be for the bridge. I think they're calling it bridging overall, bridging from one app version to another. We don't have this yet. And bridge 2, we don't have that yet either. So zone functions, let's look at the entry definitions first. Inside a zone section A, list, Inside a zone section, there is a list of zone entries for each zone, which may include the following. Name of this entry, data format, what format is the data structure. There are 3 options, string, JSON, or links. Only 3 options, but that's all you need for most types of data. Technically, you could use it for all types of data. Schema file. Also, they might have added a couple types since this documentation was written. Schema file, the name of a schema or language sharing. Okay, and this is whether it's public or private or partial. So let's look at this in the code. Okay, so in cointoss, there are 6 different types of Holochain entries that can be created. So these are our basic conceptual data types at the meaningful level in the Holochain DHT and all the entries and all the crisscrossing chains. That was weird, crisscrossing chains. So the first entry type is a handle. This is my username. The format is string. The sharing is public. The second type is a toss. The data format is JSON. The schema file is toss.json. So if we look at toss.json, we see the schema of a toss. And we saw this referenced in the return values of some of the functions. All of these things were listed. The initiator seed hash, the responder seed hash, and the call. Remember that from, we looked at some function calls that had these listed in the callback, or in the arguments. And then all of them are required for this to be valid. So a lot of our data checking actually can happen there in the schema. And then we have a type that is, and that's also public. And then we have a type which is the seed, and the data format is string, and the sharing is private. So let's look at what private said. With the value of public, entries are automatically shared to the DHT after being committed to your chain. With the value of private, entries are not shared to the DHT and remain only on your source chain. So when I said local source chain earlier, that was actually accurate, I think. So that's nice. With a value of partial, selected fields from entries are shared to DHT and structured for Merkle-proof validation of those fields while not exposing hidden ones. That's cool. Okay, so a Merkle chain is a type of chain. It's a mathematical data structure that I think it mathematizes the, getting some glitching in my video. It mathematizes what a chain means. I think Git is actually a type of Merkle chain, or a Merkle chain is a subset of Git.
Isn't it a hierarchy? It's a way of...
Let's look it up real quick. Yeah, do you know more?
This is basic blockchain. I think Merkle is something to do with making it searching for things faster, because the overhead, the computational, so there you go, hierarchy. So it's a way of being able to find things quicker with a smaller computational overhead.
I see.
Now we need somebody to properly explain it.
Yeah, and it's a very elegant data structure. It's a pretty universal type of data structure, because if you understand a Merkle tree, you can understand many different types of cryptographic structures as being a type of Merkle tree. But I don't. Yeah, let's not go into this too much, because we only have 20 minutes left. But yeah, it's structured for Merkle-proof validation of those fields while not exposing hidden ones. So that sounds very advanced. That sounds pretty cool. That allows you to share out data, and some of it is somehow validated without exposing the contents. Oh, I see. So that schema that we just looked at, this would allow some of the fields within the JSON schema to be shared in the DHT, and the other ones not, but the whole thing to still be hashed so that it can be part of a Merkle tree and quickly referenced. That's pretty cool. So then we have the, okay. So going back here, we have private for the seed, because that's private until it's revealed at the end. And then we have the toss result. Here's the structure of a toss result. It just has a toss, a result, and a timestamp, and all three are required. Oh, and I didn't look at. Oh, never mind. I thought there was another type. But that's cointoss.js with the functions. And then toss result is public. And then we have history link base. This, I think there's another functionality of this app that we didn't dive into yet, and that's the history, which displays in the window of the coin tosses that you have done. So presumably, if you close the browser and then you reload it, your Holochain app will reload your history, so you'll have a persistent history of all the coin tosses that you've ever done. And so here's some kind of base history link, which maybe links to your username using an anchor, maybe, just guessing. And that's a string, and that's public. And then there's history links, which link to different parts. And that's not specified as public or private, but I think, maybe it doesn't matter because it's a link. Or maybe the default is public. I'm not sure. So this defines all the entry types, and their schema files define the structure of the data. So this pretty strictly defines what is an allowable type of entry on Holochain. And I think every one of these entry types is required to have a validation function. No, sorry. There's just one validation function, and then inside of that you do an if or a switch to check the different types for your app. So if we look at cointoss.js, and we go to our primary validation function, which, there's no primary, there just is one. It's validate. This is called from Holochain core to my Holochain app when validation is required for from the gossip protocol, or when I'm committing an entry. If I commit something, I think validate gets called, or if gossip is happening, it calls validate also. So I'm validating other people's entries. And here there's just one check. The Holochain core programmers have been not fully filling out these validate functions yet, which is it's a practice that's going to have to change before 1.0, definitely. But for now, it just returns true. And so it checks the entry type and then returns true. So there's not actually any validation happening here. So this app is not secure and it's not finished. But that's fine because it's just a partially finished demo app. And then there's also, it looks like, a separate validate link function, which checks the link type, makes sure that it makes sense as a link See, it's checking the length of the links, it's checking the action of the links, it's checking the base of the links and the tag of the links. And if any of these are unexpected values, then it returns false and the validation fails right here. And these other three return falses. And then it does one more check. The source must be the same as the base creator. So this is checking to make sure that the link is coming from the person whose history it is, so that it's actually them talking about their own history and not someone else talking about my history. Otherwise, it returns false, and the link validation fails. It looks like there's also validate modify and validate delete. But this is the primary validate function, and we should really get this filled out so that it actually is a validating secure Holochain app. Because right now there's no validation. And getting people to write these functions, because even the core devs haven't written them consistently for all their apps yet. I'm sure they will, but they haven't yet. That's going to be an educational project and challenge, because an app is not secure if it doesn't have these validate functions.
I wonder if that could be seen though as an optional requirement, because it could depend on the level of security required for an application. So for cointoss, we could say we don't really care who's looking at the data, but if it was a banking application or something that's highly confidential, then the validation scheme then comes into play. So it's almost the platform, the operating system, Holochain, is looking ahead and seeing that these will be requirements in the future. Mm-hmm. And it's an optional, you can either trust what's coming down the pipe, or you can run the validation based on the crypto that you get as part of this. It's a part of the deal, isn't it? It's working on blockchain. You get security as part of, it comes free of charge, if you like. Hope I'm making sense here. It's good.
I didn't get the last bit.
For me. So it's almost you could make use of the benefits, the side effects of blockchain if you want to, or you could just ignore. That's how I see it anyway.
Yeah, there's some inherent security of the Holochain platform, and there's some inherent obscurity that it's difficult to hack something so complex. But yeah, and it's not about who's looking at the data. The validation functions are about continually revalidating all of the data in the application so that it matches the definition. There's some really basic vulnerabilities introduced if you don't do that. For example, if someone wanted to use cointoss to do their personal cloud storage and there was no validation function, they could inject a whole bunch of massive amounts of data into their cointosses. And then if no one's validating that to make sure that it's actually a valid cointoss, all the other nodes will replicate that data. And then you'll have your own private cloud storage stored in cointoss. So it's
not
ideally it should not be optional. Okay. You can treat it as optional and your app will be quite insecure and almost you could say like technically not even really a full Holochain app. So we need to do like a education and a tutelage project to guide people in making good validation functions, and we need to have really good documentation about what these functions mean and why they're so critical to the definition of what a Holochain app is. Those functions are actually like the functions that define your Holochain entries as what they are. Otherwise, it's operationally defined data. Yeah. Anyway, so zones. Now we're in. Oh no, we just looked at this. Now we're in functions. We were looking at entries, and now we're looking at functions. So let's look at the documentation again. Here we go. The functions that are used inside this zone that you want to expose to be callable by some other part of the Holochain system, such as a web UI or accessible to another zone. So there's the name, there's the calling type, the parameters that are passed to the function, as well as how the results are returned. The only two options are string or JSON, which will cover almost all. Well, again, any use case. You can jam a picture into a string if you really want. Exposure defines which sources are authorized to call this function. If you do not want a function in your file to be callable by any zones or anywhere externally, simply do not list it in the zones space. Functions section of the of the zones functions section of the DNA. Oh, okay. Zones dot functions. That's what they meant. Function of the DNA. Options. If exposure is left off entirely as a property, the function defaults being usable only by other zones in the app. If set to public, the function is callable by anyone and over the web server. Okay, so let's look at our defined functions. We have who am I, which takes a string and is public. We have set handle. I didn't see who am I. Let's see if we can find that. I bet it's here, and I just didn't see it. Yeah, there it is. And it just returns me, which is my app hash key. Oops, here we go. And then we have set handle, which sets your username, and it takes a string, and its exposure is public. We have get handles, which takes JSON and is public. Get handle, which takes a string and is public. Get my handle, which takes a string and is public. Get agent takes a string and is public. And here's the meat of our app. We have request toss, confirm toss, and get toss history. Request toss takes JSON, confirm toss takes a string, get toss history takes JSON, and is public. So again, we didn't look at history. So these two functions, just request toss and confirm toss, are the only two functions related to the core functionality of our app, which are exposed as Holochain API functions that can be called by the front end or called by other Holochain nodes. So request toss is called by the front end. Confirm toss is, I think, called from one node to another node, probably. And so if we look here, though, we're looking at all these other functions. We've got, so request toss is public, but commit seed is not, commit toss is not, confirm seed is not. So these are all functions which are called internally by one node to itself, and they're not exposed as Holochain API functions. They're not exposed as Holochain functions of the app. They're called either just internally, or perhaps they might be called Holochain to Holochain. I'm not totally clear on that because of this send function that we are looking at up here. There might be like a workaround. But let's look at that one more time real quick. Here it is. Send toss request. No, yeah, that's gonna be a request toss. So yeah, there's just two ways that Holochain apps can do coin toss requests and confirmations, and those other apps are helper functions, which are internal to one instance of a Holochain app. And again, these are separate from the entry types, so the different entry types that are generated and committed by those might be not related to the functions exactly, one-to-one. Cool. So does that all make sense? We've got our functions, we've got our entries. Yeah, it makes enough sense to me too. And then we have anchors. Anchors is a newer feature that allows you to put names into the DHT and then refer to those names, those anchors, and use that to keep track of some type of, I want to say centralization, but it's distributed. It's the centralization of naming something. So that we can all, for example, reference the same history or reference the same user, that kind of thing. So you can hang your history off of your username and then people can find it, for example. So here we have anchors. This is the anchor zone. The ribosome is JS. The code file is anchors.js. So I think anchors is supposed to be, I think anchors has probably been changed in its implementation since this cointoss example was written. I'm pretty sure anchors is now a Holochain core feature. And I think that, I'm not sure, but I think that this was written when anchors was a mix-in or a library. So this implements anchors, and it's a rat's nest of JavaScript. very nice JavaScript, but it's still JavaScript. And this implements that anchors feature. But I'm pretty sure it's now in Holochain core, so you can just call anchors functions. Like similar to commit and not send, but get. Commit and get in those functions, you can now call anchor related functions, I think. But anyway, this is going to be another zone. Oh yeah, so we actually have two zones. See, we have the cointoss zone, and then we actually have a second app, which is rolled into this app, and it's the anchors mixin, the anchors app. And so we have a whole another set of entries, anchor base. I'm not going to go into this because it's not cointoss, and we didn't look into this, but we have anchor base, anchor link, anchor generic, anchor JSON type for testing, lovely. And we have functions named get, set, add to list, get from list, remove from list, and make anchor hash, because it's content-based addressing. So we're hashing the content of the anchor to make its hashed. And that's actually how you find anchors on the network, is you type in a string, you hash it, and then you request that hash from the DHT. It's a really elegant way to make strings look upable. But yeah, let's not spend too much time on that, because that's effectively a separate app, and we were diving into cointoss, and I'm pretty sure anchors is outdated and is now included in Holochain core. So there's a DNA file.
Some feedback to a Holochain advocate. I've learned more in the last hour going through the interface file than any time before, but I think that must be dependent on your background. So that made a lot of sense to me, and how the system fits together. I don't know whether would you agree with that, Fali?
It had me look at the overall ecosystem from another point of view, I would say. Because I've heard the general explanation before, meaning the local source chain, DHT, and so on, but from more from an abstract point of view, and here it's more hands-on.
Yeah,
and I find those perspectives complement each other well.
Cool. Well, thank you very much. That means a lot, both of you.
In the perspective app that we're talking about, building from the ground up, it would be useful to see how the anchors now, because you've said that's now in the core library, how that can work, because that'd be mixing. It'd be interesting to see how you can put things in the DHT and come back another day and to be able to retrieve that, you know, to actually see it as acting as a database even. So I'm looking forward to that.
Yeah.
Well, that's all it was. It was just some feedback to, you know, if you're maybe as a live, if you're doing a conference and you're doing a live code, zipping through the interface file may be useful for people with programming backgrounds.
Yeah. Oh, I see what you're saying. Yeah, doing the DNA first before the code. Yeah. Thank you.
Yeah.
That's good feedback. Thank you.
Also, the terminology is quite different, but it's quite revealing, zones and things like that. And
thank you.
Right. So I'm looking forward to the next one.
Me too. Yeah, we're just at 2 hours right now. I was just going to say the really beautiful thing about Holochain apps is that it's all on the surface. Like, yeah, the definition of the entire app is right here, and this gets hashed, or maybe, this gets hashed, and then, or maybe the code gets hashed, and then that guarantees that it's exactly the same app. And then all of the functions that are, that the app actually does in the distributed computational environment that is Holochain are all right here, and it's visible. And because you have to hash the code in order to prove that you are running the same version, all Holochain apps are basically required to be open source, de facto open source, not necessarily legally open source. So it's so open. It's like enforced openness on the entire scale. Anything that happens on the network starts as completely open and has to be that way. So it's really beautiful. And if you programmed other types of systems, you know that they're all about like enclosing all of the horrific mess and hiding it away so you don't have to think about it. And instead we have something that's like elegant and open at the beginning. It's beautiful.
It'd be interesting to see if this is the correct way to think of that, because I've got a gut feeling it's not, but it feels like what you've explained there is a bit like a checksum. So, you know, when you're obtaining binaries from places, especially from GitHub, you will get the binary plus the checksum. So you can do your own test just to make sure you're not, you know, downloading viruses or something that's already been compromised. So whether that's, you know, you could explain that to other people to say this is the way it's hashed and it's a bit like a checksum. I wonder if the designers would agree with that. Yeah,
a hash is analogous to a checksum.
Yeah,
but a checksum is much less secure, of course.
Yeah.
Cool. Okay, great. Well, it's 2 hours, and so let's. I'm going to stop the recording.
When do you
thank
think
you
the
guys
next
so
one will
much for
be?
coming. I'm trying to do them on Wednesday or Thursday every week.
Okay.
But I have no idea where I will be a week from now because we were originally planning to travel, but that might not happen. So, but I'll try to do next Wednesday.
That's good with me. Will you be with us next week? Hello?
Thursday works better for me in general. Most of my Wednesdays evenings are taken, but
okay, I can try to do Thursday actually. Let's do that. I'll plan on Thursday tentatively.
Okay, sounds good.
Does that work for you, John?
Yes.
Cool, great. And I'm going to try and get this announced on Facebook next time. So maybe we'll have a few more people showing up for this. We'll actually program a Holochain app from scratch, trying to make a dice app with the current version of Holochain. Great. Thanks for coming. I'm going to stop the recording.
Yes. Thanks again.
Awesome. Thank you.
See you next time.
Yeah,
Bye.
thank you so much. Bye.
Thank you.
Thanks again.
Thanks. This was really fun.